Hey, this is OXDF. In this workshop, we're going to be doing 3 of the more beginner-friendly forensics challenges from last year's Cyber Apocalypse CTF. Um, we're also going to do a little bit of digging in, kind of going beyond root, beyond the flags, actually understanding the challenges and what they present and how they mimic real life. So even if you're not a beginner, hopefully this will be useful for you and you might learn something. With that in mind, let's go ahead and jump in. We're going to start with Alien Cradle. Um, so last year's CTF had a story where there's aliens coming to try to find some relic, and I don't remember exactly the details, but Pandora is our hero. And so, if we kind of skip ahead here, we can see uh, they found in PowerShell logs, they found a PowerShell Cradle, a short script that's designed to download and execute a next stage. And I'm gonna say they're gonna say it's obfuscated. It's very slightly obfuscated, and they can't understand it, and so we need to help figure it out. I've already downloaded the files here, so we'll jump over into this VM. We can see I've got cradle.ps1. We can look at some metadata about it right away. If we do a word count on cradle.ps1, we'll see it's actually got 0 lines, which just means it's all on one line. There's no new line. If we go ahead and cat it, you can see we're right. It's all on one line, no new line. We could start to piece together exactly what it's doing here. But something like this, it's probably not totally necessary for here. I like to go into something like VS Code, get myself a nice editor. We can let's make this a little bit bigger so it fits on the screen. There we go. Close the terminal. And we don't need sneak for this. Alt Z will wrap the lines for me. Control F will bring up the find thing. And so what we have here is a bunch of PowerShell commands on one line, separated by semicolons. And so we'll do a Control F for semicolons, and we can see there's 7 of them. If we down arrow here and replace, a Shift Enter will actually give me a new line here. And now I can just do replace or replace all. And now all the semicolons are gone and all replaced with new lines. So already I can start to figure out what this is doing. We can probably jump right here and just if you've done CTFs before, you can see this very clearly is the flag. You have HTB squiggly bracket with some stuff in between. But I want to take a step back and approach this a little bit more forensically. And there's really 2 things we can look at here. First, we look at this first line, and we can see if system security principal Windows identity. So if the current user, we're using that to get the current user, and if their name is not equal to secrethq/arth, then exit. This tells me right away, this is a targeted attack. This is not something they sent out to half the internet hoping to get in somewhere and ransom something and try to get some money. This is somebody who is interested in targeting Arth at Secret HQ. When I worked in a SOC, one of the main things we were required to document on every ticket was whether it was a targeted attack or just an attack on everybody. And that's not going to change how I forensically go in and try to make sure this didn't run, what domains I might block at the firewall, etc. But it is going to let me know what level of attention I should pay to this. And so when I have them targeting a specific user in only my network, that tells me somebody's job is to get this information from Arth. And if I stop them now, they're probably going to come back tomorrow. And so I should look for as much off of this as I can. Any additional indicators I can find, any other blocks I can put in place, I'm going to want to do that. So that's just more useful to know. Lines 2 through 7, with the exception of 6, is really a really standard web cradle, PowerShell cradle. And what that basically is saying is, we've got this. We're going to create a web client. We're going to tell the web client to use whatever credentials are the default proxy credentials in this network. We're going to download something from this, in this case, windowsliveupdater.com. And we're going to save the results in this variable D. And then we're going to decompress. Did we lose? Let's see. Oh, yeah. No, sorry. We're going to decompress. We're going to turn that from base64. So we're going to base64 decode that string into the variable S. And then we're going to gzip decompress that and pass it to IEX. And now IEX is the invoke expression. It's a shortcut for that, so alias for that. So basically, we're going to download something and we're going to run it. And this gives the attacker a few benefits. For one, this script is pretty small. They might be able to slip it through a firewall, maybe more unnoticed, or maybe help avoid AV or EDR. The other thing this gives them is they can change the response they give based on different criteria. So after the first time it's downloaded, maybe they don't want to the next time they give a benign payload back, or they give back something, or they just take it down so it's not there. Or maybe they have IP filters, so they already know what Arth's username and domain is. So maybe they know what IP they expect this to come from. And if Arth were to send this off to a researcher or somebody and they try to download it, they'd get a different payload. So there's all sorts of things you can do with these cradles that provide benefit to the attacker. So that's why you're going to see them. But in this case, not much else to see here. If we actually went to this Windows Live Updater, I believe it's actually just a Rickroll, so nothing really to get out of that. But that's about it. The second thing we can look at is how you deobfuscate things in PowerShell. Now, this is such a simple example. We could probably just like spend some time deleting some single quotes and we'd get the flag. But it, I like to think, let's think a little bit more big picture about it. Can we do something to actually get this deobfuscated? And the answer is, let's run it in PowerShell. One thing you want to be careful when running things in running malicious things in PowerShell is a lot of times you'll see like if F here we're actually being passed to IEX, like some sort of obfuscated string that then gets passed to IEX. You don't want to run the IEX part because that's what's actually going to invoke the expression. Take this thing and run it as code. But then if you could take the stuff inside of it and run it, feel pretty safe about it because it was being passed to IEX. So it's just decoded into strings. So that you're good with. In this case, we don't have to even really stress about that. The other thing that's really nice is you can do this in Linux. So if I do pwsh here to run PowerShell, now if I paste this in and run it, it ran just fine. If I did accidentally run something, it probably, unless the payload was set up to run on Linux, it's not going to actually infect my host. So that's another just tip we can use. Let's see if we can run that. So we can grab this flag here. We can submit it to the platform, get our points. I think that's about it for Alien Cradle. Let's go ahead and jump over here to the next one, and we're going to take a look at extraterrestrial persistence. There's a rumor that there's a persistence mechanism that's impossible to detect. After investigating a recently compromised server, Pandora found this sample. Can you figure out what they're doing? So we'll jump back over here. I'll go to my next terminal window here, and I've got persistence.sh. If we take a look at this, it's a bash script, and it's pretty simple. We can take a look at this starting at the top. So the first two lines is going to run the command whoami and save it as the variable n. It's going to run the command hostname and save it as the variable h. It's going to save user local bin service as the variable path. And now we do a check. Now again, we're being targeted. Again, it's another thing being targeted. So in this case, we're targeting Pandora on the hostname Linux HQ. And if either of those things don't match, then we're going to exit the script. Assuming those do match, there's one thing that's a little bit weird here because we're going to do some stuff in a second that could only be done typically on a Linux system with root privileges. So it's a little bit weird that you have to be running as Pandora, but we'll go with that for now. So now, assuming we don't exit, we're going to curl. We're again, similar to the Cradle before. We're going to download from a URL from files.pypy install packages service blah blah blah, and we're going to save it as user local bin service. We're then going to do a change mod, which is to set this thing executable, and then we are going to run this echo -e with a bunch of base64 encoded data, and you recognize base64 because it's all uppercase, lowercase, digits, and then slash and plus. And then at the end, you might have equal signs. So anytime you see one or two equal signs at the end, a bunch of stuff like that, you feel pretty good. It's base64. But even without that, you can kind of recognize it. And then, even if we didn't recognize it, you can see, what's it doing? Well, it's piping. So take the output of this echo command and send it to the base64-decode command. And then the result of that is going to be saved into this file, which is a service file. Now, on Linux and systemd uses these service files to run services on boot or other times. So, and then you can see they actually run system control enable service.service. So that is going to say basically on every reboot, go ahead and run this service. So what's left to figure out here? Well, it looks like we're downloading something and then we're setting up a service to run it. We might as well take a look at the specific service, and we can just go ahead and grab this right here, copy that, paste it in, and we get the output is what's being saved in the service file right here. Now we got our flag right here, so we've solved it. Just a simple base64. We've got the flag, but let's take a little bit look. So the exec start, we're gonna remain after exit. So it's gonna run and it's gonna keep running. The exec start is gonna run our service, and if we try to stop it, it's gonna run our service binary. So effectively, what this is doing is persistence. What we talked about. So on reboot, run my malware again. So another one. This is very quick, but this is the type of thing you might see. Let's go ahead and take a look at the last challenge. Now, this one's going to be a little bit more in depth. We'll go over here to Packet Cyclone. And so I've actually already pushed the start button here to get myself an instance. I'll copy this. Pandora's friend and partner Wade is investigating for the Velux location. Noticed some weird traffic. He believes it's compromised. basically, let's see, let's skip ahead a little here. They want us to use a tool called Chainsaw and the Sigma rules provided to detect usage of rclone from the event logs produced by Sysmon. To get the flag, you'll need to start and connect to the Docker service and answer questions. So this is going to give us questions we have to answer to get the flag. Let's go back over here into the VM, and we can do that right away. Let's go here. If we do a netcat and we have this thing, and we just have to replace that colon with the space, and here we are, we have our questions. So we get the exact same description up here, and then what is the email of the attacker used for the exfiltration process? So we don't know what's going on there yet. Let's actually go. The first thing we need to do, I guess, is look at what is. They mentioned using Chainsaw. Chainsaw is a tool, a super useful tool actually, for parsing through event logs and making them more readable or searchable, etc. They can also use Sigma rules. Now, Sigma rules are rules that are meant to ways that you can sort of write rules to recognize certain patterns or behaviors. And so we'll look at both of those throughout the course of this. We're going to start by downloading Chainsaw. So we'll go to releases. I'm on Linux, so I'm going to grab this URL right here. We'll just copy the link, jump back here. I'm going to go to my /opt directory. Now, by default, typically only root can write in /opt. One of the things I do on my hacking VMs is just make opt world writable because I want my user to be able to download tools. You could also just run this with sudo if you want, but I'm going to go ahead and grab this. And then I can, let's see, unzip -L Chainsaw. Let's do this. Is that not? Oh, it's not zip, it's tar. We'll do a tar tf Chainsaw. And that'll list the files. So T is what you use to list, and then F says take in this file. And we can see the files we have are all in the Chainsaw directory, so I like that. So we'll do a tar extract file, same thing. And I love alt period to get your it gives you the last word on the previous command. If you can just run it again, so you don't have to fill that out. And now we can go into Chainsaw, and here we have what we need. The Chainsaw binary itself is right there, as well as this mappings directory, and we're going to need both of those. One thing we can also do, if we want, is we can go to something in our path. So like for me, local bin, I can do an ln of, let's see, opt chainsaw into local bin. And what that just did, if we look in ls-l of local bin chainsaw, we just created this this shortcut right here. And oops, I did not make a symbolic link. Let's do that SF like that. And there you go. So basically, ln-s will make a symbolic link. And you can see now in my local bin chainsaw, it points to this. And what that lets me do is anywhere now, I can just run chainsaw, and I can run chainsaw because it's in my path. So let's go back to this. And we probably want, actually, let's go 3. We'll go back to, what was this? What directory were we in? Cyberopocalypse. Okay. EA24. And we want to go to packet cyclone. And we have logs and signals. We should now check out our data. So if we do an ls on logs, it's actually quite a few EVTX files. I think they're all EVTX files. In fact, we can figure this out. Let's see. We want to do a cut on delimiter of period. And then we want to get, we can see if we can try to do it with just 2. And then we can do a sort -u. And you can see that they're all, and so sort unique basically says sort them all and just keep the unique ones. And so everything is EVTX. So we've proven here all our logs are EVTX. So we have a lot of those. What is in our Sigma rules here? If we want to open one of those up, rclone, let's see, rclone config. And so this is a YAML file that defines some activity that we're looking for. So we have a title of rclone config file creation. It's going to detect the file being created. It's experimental. It's got a date. It comes from someone from the NCC group. That's a reputable group. We have a blog post here that shows us exactly why they're trying to detect it. They actually talk about false positives. So what are the false positives for running this rule? Well, if someone's legitimately using rclone, you're going to flag this as malicious. Now, on your network, if someone is running rclone, you should probably know that. I mean, that should be documented somewhere that that's a tool that's supposed to be used. So that's why they're saying it should be rare. Maybe on your home network, that would be different. Then let's see. So we're going to look in Sysmon. Detection is if we have an event ID with a target file name of cusers something .config rclone something. And so if a file gets created like that, it's going to set this rule off. We can take a look at the other one. Sigma rules rclone and execution. And it's very similar. Let's see. So we have the title, the description, a lot of this is the same. Legit rclone usage, again, rare. Now we're looking at process creation. And so if the image ends with rclone and the parent image ends with PowerShell or CMD, and so basically that's what we're selecting. And then if the command, so like one of the command line arguments is pass user mega sync blah blah blah, those are things we want to flag on. And so the condition is if this is one of these exec selections and one of command selections. So basically this is almost like if you've ever been familiar with Yara rules, which is like a similar language to this, where you can look for different patterns within files, binary patterns especially, or strings. This is looking through logs. Sigma rules help you look through logs to find different events. So we've got that. We've got the Sigma rules. Now we can go ahead and actually run it. So we can do chainsaw, and we're going to give it a dash. Probably pull up the help here. Let's see. So we're going to do a hunt. So chainsaw hunt is our command. And now, let's see if we can get a help on that. Nice. Okay, so we want I think our logs file is just, so it looks like we're going to give it rules and then a path. So we're going to say, can we just use Sigma rules and logs? No, I think it's dash S. Oh yeah, dash S for Sigma. Let's try that. Perfect. Okay, so now it's telling us the following arguments were not provided, mapping. We have to give it a mapping. So if we can go up here and see what is our mapping. A mapping to tell Chainsaw how to use the third-party rules. And you kind of just have to know this with Chainsaw. But if we go to op Chainsaw, there was a mappings directory here. And there's really two in here. We can do logs all or logs legacy all. Without knowing too much about it, I'm just going to choose the one that's not legacy and see if that works. And you can see here it's actually running, and it kind of worked here. Let's ugly. I'm going to make my script text a little smaller. We'll go back up when we actually start looking at this, but you can see it's found two detections. One of each of the rules has fired, and it tells us the timestamp, the detections, the providers, as well as a bunch of data about the event data. Now, if my text is really big because I want this to be really visible on the on this workshop here. So what I'm actually going to do is we will run this again. With the -JSON flag. And that's going to give us a nice JSON blob here. Now that's still pretty ugly. But one of the benefits is most of this output, except for the JSON, is actually being sent to standard out or standard error. So we can pipe this into my favorite tool, JQ, and give it a dot, and it will break all of that JSON out into actually readable structured data. And then the one other thing I'm going to do is I'm actually going to pipe that into less. We lose the colors, but we can now easily scroll up and down within our file. And we've got data here. So we can take a look at the things that were run. So first we have, let's see, do we have the name in here? So yeah, here's rclone execution via command line or PowerShell. And then if we scroll down to the bottom here to the next one, rclone execution via command line or PowerShell. So we have the same one firing twice. And we can look through these and actually figure out the command lines that were run. So C users wade app data local temp rclone.exe. It seems like a weird place to run an executable out of, especially one that would be legitimately installed typically. So it seems suspicious. Config can create remote mega user. We have an email address and a password. That's pretty good. And then we might as well scroll down to look at the next one. And same thing, we have the same rclone.exe being run. And this time we're actually copying data out of user remote desktop location to remote exfiltration. So we're actually going out to the remote and we're copying that folder, which includes the relics locations. That's what the bad guys are trying to get. So we definitely want to catch this, right? So now I think we have enough understanding to go back here and try to answer the questions. So what is the email the attacker used for the exfiltration process? So we definitely have that right there. Proton mail. All right, what is the password of the attacker used at the exfiltration process? So we can look at that, and that's going to be this password right here. So what we have here is actually the user is creating a remote through rclone, logging in basically as this user and password into Mega, which is a cloud service. So we can put this here, and that looks correct. What is the cloud service? We just literally said that out loud, Mega. What is the ID of the process used by the attackers to configure their tool? So that's this right here. We're configuring it. So the process ID is actually right here, 3820. If we scroll down a little bit, we can see the execution attributes. Yeah, 3820. This seems like the parent process ID is right here. So we can see it's actually running. It runs PowerShell is what's running rclone. So again, it's possible Wade is in there doing it, but we pretty clear it's malicious activity. So we'll grab 3820 here and enter that, and we got that correct. What is the name of the folder exfiltrated? Provide the full path. So that we saw down here in the second log. We are copying this right here. And let's go back. We're probably going to need to get rid of these. Whoa. Can we not paste? I'm probably not going to like that. Yeah. Okay. So it's C, users, Wade, desktop. Actually, you want to see it? We can show a quick trick since we have time. I think this will work. Let's see. If instead of just connecting there, if I do an RL wrap connect, yeah. Let's see. So we can let's grab this, copy, paste. That works. Grab you. Next one's Mega. ID of what was it, 3820? Yes. Okay. And what is the name of the folder? So let's go back here and grab this folder again. And they don't want, looks like now because we used RL wrap around our netcat, we can actually use arrow keys to move around in our input here. Oops. And do that. So that'll work nicely. RL wrap is something I use almost every time I get a shell in a Windows box, but it's also useful for these kinds of netcat connections where you just want to be able to, it gives me up arrow, though that's not super useful here. Well, I can try. So if I try with it on the end, it didn't like that, but now if I up arrow and get rid of it, it did like it. So I get up arrow, I get the other arrow keys in general, I can move around and delete. So that's useful. All right. What is the name of the folder the attacker exfiltrated the files to? I'm going to say it's probably exfiltration. If we paste that in, and we got it, and it gave us the flag. So we could take that and submit it. Yeah. So this was kind of a speed run through 3 of the challenges from last year's thing. Hopefully, I think the Hack the Box has been doing a better job over the last few years of really trying to make sure there's some beginner-friendly content at each of the challenge levels. That's easier for forensic than it is for a pwn category, but still, it's good to have it out there. So this should hopefully give you a bit of a confidence boost if you're a beginner going in. You can do this stuff. You probably won't do it as fast as I just ran through it, but these are the types of things you can figure out, and these are the types of things you can learn from. It's super valuable. Go in and have fun, enjoy yourself, and hopefully you learn something, and enjoy the CTF. I'll talk to you next time.